So this is Dr. T. Venkateshwar Rao, Professor, DBS Institute of Technology. So today I am going to explain boilers. So boiler is one of the very important mechanical component in the field of engineering. So generally the boiler we use in the field of power generation. So for power generation we require steam, and steam can be generated only by boiler only. So from the few centuries onwards, in many countries, people are using boilers for steam generation. In turn, that steam we are using for power generation. Okay. So wherever there is a power generation, there the boiler. Wherever there is a power generation, there boiler makes very important a key role. Okay. In the power generation. Okay. So that means boiler we are using for steam generation. Okay. So steam we can produce with the help of the boiler. For that we are using water. If you send the water to the boiler with the help by taking heat from the outside, so it generates the steam. It generates the high pressure steam. That high pressure steam will send to the turbines and will generate the power. Okay. So this is about the boilers. So boiler is an apparatus to produce steam. So we define boiler in a simple way. So boiler is an apparatus to produce the steam, and how it is producing the steam is with the help of taking heat. That means it takes the thermal energy from the outside. It takes the thermal energy by burning of fuel, and in turn it produces the steam. So the steam means generally the steam is at a very high temperature, that is more than 100 degrees centigrade. So if it is a superheated means it is more than 200 degrees centigrade also, and pressure also increases automatically. So what for we are using the steam means the steam we use for generating power in steam engines, steam turbines. So nowadays we are not using steam engines, but steam turbines we are using for power generation. So not only for power generation, the steam we can use for some other applications like heating the residential and industrial buildings. Okay. And at the same time, the steam in some process industries also we use. What are the industries we use means the steam we use in the case of sugar mills, chemical and textile industries, we use steam. Wherever we require steam, there we have to use boiler. So boiler is an important mechanical component for the generation of the steam. Okay. And so how to select the boiler? So there are later we discuss different classifications of boiler. So before going for the selection of a boiler, what are the things is very important, we'll see. The selection of a boiler, it depends upon the working pressure and quality of steam, and type of steam generation, floor available. So whether in a small space we have to arrange a boiler or a bigger space is required for the boiler. Accessibility of repair and inspection, compared to initial cost, the fuel and water available. So sometimes some places there is a very sufficient quantity of water will be available. Some places sufficient quantity of water is not available. Okay. Some sufficient quantity for water is available. There we use different kind of boiler. If water is not available, there we use different type of boiler. Operating and maintenance cost. So these are the parameters generally we use while selecting the boiler. And there will be some properties generally we see while designing and selection of a boiler also. That is safety. Safety, accessibility, capacity, efficiency, simple in construction, the initial cost, maintenance cost, and capable of quick starting and loading. Okay. If you want to start the boiler, means it takes some time. Immediately, as engine, we cannot start. First of all, we have to heat the boiler and it takes some time. So safety. Okay. So safety means since we are the boiler produce very high pressure steam. The high pressure steam, we want to maintain the high pressure steam in a vessel means we have to maintain a lot of safety precautions. Otherwise, there will be explosion may happen. That's why. So we have to follow a lot of safety precautions. If pressure exceeds particular limit, there will be safety valves and all these things we have to see. Accessibility. The various parts of the boiler should be accessible for repair and maintenance. If you want to repair any part means it should be accessible. Capacity. So generally, as per capacity, there will be high pressure boilers and low pressure boilers. Okay, like this, the boilers are classified. Okay. Efficiency. So should be able to absorb maximum amount of heat produced by burning the fuel. Whatever the fuel we burn, the maximum amount of heat is to be transferred from burning to the steam. So then only the efficiency of the boiler will be more. And it is simple in construction, and costing should be low, and it should be easy starting and loading also. Now we are going to for the important part of the boilers, that is a classification of boilers. The boilers may be classified as, there will be different classifications, we discuss one by one. Horizontal, vertical or inclined boilers, fire tube and water tube boilers, externally fired boilers and internally fired boilers, forced circulation and internally fired boilers, high pressure and low pressure boilers, forced circulation and natural circulation boilers, stationary and portable boilers, and single tube and multi-tube boilers. These are the various classifications of boilers. Now we'll discuss one by one. First classification is horizontal, vertical or inclined boiler. Okay. If the boiler should have an axis. If the axis of the boiler is horizontal, it is called a horizontal boiler. If the axis of the boiler is vertical, it is a vertical boiler. If it is inclined, it is inclined boiler. Like that, based on the axis of the boiler, we classified the boilers are horizontal, vertical or inclined boilers. And second classification is fire tube and water tube boilers. In the fire tube boilers, the hot gases are inside the tubes. When the hot gases are flowing inside the tubes and the water is surrounds the tube, that is outside the tube, and inside the tube there is a hot gases, then it is called as a fire tube boiler. Or water is flowing inside the tube, then it is called as water tube boiler. If the water is inside, it is a water tube boiler. In particular case, if fire is inside, then it is called as fire tube boilers. So in fire tube boilers, coherent and locomotive boilers are fire tube boilers, and Stirling boiler is water tube boiler. And another classification, externally and internally fired boiler. If the boiler is known as externally fired, if the fire is outside the shell, there will be a shell. Okay, outside the shell, outside the boiler, if we are firing, we are burning the fuel, it is called externally fired boiler. Example, Babcock and Wilcox is a externally fired boiler. If the firing is inside the boiler shell, then it is called internally fired boiler. Coherent boiler and Lancashire boiler is internally fired boiler. And another classification is forced circulation, natural circulation. So forced circulation means we use pumps. In forced circulation type boilers, the circulation of water is done by the forced pumps. So what if you, with the help of the pump, if you pump the water, what happens means the pressure of the water increase. Okay, if you use pump means automatically the pressure of the water will increase. So like this we create the high pressure. Example, Wilcox and Lamont are the forced circulation boiler. In case of natural circulation, the boiler circulation, the water without the help of pumps, if you send the water to the boiler, it is called natural circulation boilers. That is Lancashire and Babcock is natural circulation boilers. This is very important classification, that is high pressure and low pressure boilers. So how we define the high pressure boilers means, if you produce the steam more than 80 bar, 80 bar means 1 bar means 1 atmospheric pressure. 80 bar means 80 times of the atmospheric pressure. If you produce the steam more than 80 bar, and respective boilers are called high pressure boilers. Wilcox is high pressure boiler. If the pressure is less than 80 bar, it is called low pressure boiler. Coheron is low pressure boiler. So single tube and multi-tube boilers. The 5-tube boilers are classified as single tube and multi-tube boilers, depending upon the 5-tube, 1 or more. If there is only one 5-tube, that is a single tube boiler. If it is more than one 5 tubes, that is called as multi-tube boilers. So boilers generally mainly classified as 5-tube and water tube. Okay, some boilers are 5-tube boilers, some boilers are water tube boilers. We'll see one by one. Okay, so if it is a 5-tube boiler, the 5-tube boiler seems to be like this. Okay, so here there is a furnace. So this is a furnace. Inside the furnace we burn the coal and some other, mainly coal we use as a fuel for boilers. In some case, some other waste material also we'll use. Generally 90% cases we use coal and sugar waste. Here we burn the fuel. If you burn the fuel, means hot gases will be produced. The hot gases are flowing through the tubes. Hot gases are flowing through the tubes. Since hot gases are flowing through these tubes, then it is called as 5-tube boiler. Okay, and around the tube there will be a very big drum. Inside the drum, the 5 tubes are arranged. Okay, so in the drum, what happens means there is a heat transfer from 5 tube to the water, and in turn temperature of the water rises and steam generation takes place. Whatever the steam is generated, that will be accumulated on the top of the drum, and from here we take the steam out, and the hot gases, it flows through the tubes and it leaves the boiler through chimney. Okay, so this is, we can call it a smokestack. All the pipes are connected to this exit, and from this chimney, the chimney or the exit, hot gases leave the boiler. Okay, so this is the working principle of 5-tube boilers. So similarly, next classification is water tube boiler. In case of water tube boiler, so here also it is very similar construction. There is a furnace, and here, so inside the furnace there will be water tubes. So water we are sending through these tubes, and the hot gases are flowing around the tubes. When the water is flowing through the tubes, there is a heat transfer, and when it is flowing, the water is by absorbing the heat from the furnace. When it is flowing through the pipe, it becomes a steam, and from the exit of the steam, exit of this water pipe, we take the steam outside. Okay, and the hot gases leaves through the exit of the this smoke stack. Okay, so this is the working principle of water tube boiler. Now we'll see the comparison between fire tube boilers and water tube boilers. So here we have taken so many parameters for the comparison. So if you take mode of firing, so mode of firing means starting. So fire tube boilers are internally fired, and water tube boilers are externally fired. That means in case of water tube boilers, we fire out from outside, we burn the fuel outside. Rate of steam production, in case of fire tube boilers, it is low. In water tube boilers, we can produce more amount of steam. Construction, it is difficult in case of fire tube boilers. It is simple in case of water tube boiler. So transportation, it is difficult in case of fire tube boiler, simple in case of water tube boilers. So treatment of water, not required, not necessary for fire tube, but treatment of water is required for water tube boilers, because so whatever the water we are sending to the water tube boilers, so if you not cleaned, there will be scale formation takes place inside the water tubes. Okay, and so that becomes it reduces the life of the water tube boilers. Operating pressure. So operating pressure, it's limited to 16 bar. That means fire tube boilers we use only for low pressure as a low pressure boiler. So in case of water tube boiler, that is 100 bar. Operating pressures will be 100 bar. That means for high pressure boilers, we go for water tube boilers. Floor area, more floor area is required here and less floor area is required in water tube. And shell diameter, a large diameter for fire tube and small diameter for water tube boilers. And explosion is very less in case of fire tube boilers and more in case of water tube boilers. Risk of busting is less in case of fire tube and more risk is there in case of water tube boilers. So now we will discuss some specific cases of fire tube boilers. There are mainly 5 types of fire tube boilers. One is simple vertical boiler, coherent boiler, Cornish boiler, Lancashire boiler, locomotive boiler. We will see how these boilers are looks like and what will be the respective working principle. So this is a simple vertical boiler. So there is a vertical drum. Inside the drum there will be a furnace. Okay, and inside the drum we fill the water, and the water is around the furnace. Okay, so it consists of a cylindrical shell. This is a cylindrical shell, a greater portion of which full of water. The water is filled in the shell, vertical cylindrical shell, and the remaining is the steam space. So this central space is a steam space where we burn the fuel. At the bottom of the firebox, it is a grate. Grate means grate is a plate where we keep the fuel and we burn the fuel. Okay. So once we burn the fuel means the flue gases will move up, and after burning the ash will drop from the grate to the ash pit. Like this, there will be heat transfer. Due to this burning of fuel, there will be heat transfer. In turn, steam will be generated, and the generated steam will be collected in the top of this water, and from there we will take the steam. In case of coherent boiler also is similar to the vertical boiler, but in case, so here there will be a horizontal fire tubes. So there will be horizontal fire tubes, and the water is filled here. Okay, so due to horizontal fire tubes, there will be heat transfer from fire tubes to the water, and steam is generated. Generated steam will take from the top of the boiler. So coherent boiler consists of a cylindrical shell with a dome. So in coherent boiler, we can observe there will be a dome-shaped structure at the top of the boiler. So due to that, we can collect more amount of steam. So this is a fire tube boiler. Okay, already we have discussed. So there will be a furnace, there will be a fire tube. The hot gases are moving around the fire tube, and around the fire tube there will be water. Due to heat transfer, so from the water the steam is generated. Generated steam will be collected here and will take the steam. So Lancashire boiler, this is one of the important boiler. So Lancashire boiler is a fire tube boiler. So here, this is the side view, this is the front view, and this will be the side view. In side view, you can observe that there will be two fire tubes. There will be two fire tubes are separated. Okay, in both the fire tubes, the hot gases are moving around the boiler. Okay, outside the fire tubes there will be water is filled around these two fire tubes. Okay, so there will be heat transfer from the fire tubes to the water, and due to heat transfer the steam will be generated, and generated steam will be collected at the top of the boiler, and from the top we take the steam out, and there will be a lot of accessories or mountings are arranged at top, that is a safety valve and pressure regulator valve, and like this there will be a lot of mountings are fixed at the top of the shell boiler. This is a locomotive. There is another one is a locomotive boiler. Locomotive boilers generally we use for railway engine purpose. Since railway is, so that's why there is another name is there. It is a portable boiler also. It is a locomotive boilers are portable. This. So these boilers can move from one place to other place due to the application of the boiler. So locomotive boiler is also a fire tube boiler. So if you observe, there will be a big horizontal drum. Inside the horizontal drum, we fill the water. So inside the water, so there will be so many fire tubes. One side of the fire tube there will be a furnace. So inside in the furnace we burn the fuel. So it produces hot gases. Hot gases are flowing through the fire tubes. And since hot gases are flowing outside the tubes there will be water. There will be heat transfer. Due to heat transfer, water gets heated, and steam will be generated, and generated steam will be taken from top of the locomotive boiler. Okay, so advantage of the locomotive boiler is large rate of steam generation per square meter of heating space, and to some extent this is due to vibration caused by the motion. It is very compact. The pressure of the steam is 20 bar. Okay, generally fire tube boilers are low pressure boilers. That's why pressure is only 20 bar. So there is till now we have discussed the classification of fire tube boilers. There is a water tube boilers also. There is a classified as long tube boilers and cross drum boilers. And the cross drum also single 2 drum, 4 drum, 3 drum boilers. And there is a bent boilers. There is another classification, bent boilers. Okay. So like this, the boilers classifications we have discussed. So this class we have discussed what is meant by boiler, how we define the boiler, what is the applications of the boiler, how the boilers are classified. So boilers are classified as mainly fire tube boilers and water tube boilers. So fire tube boilers are low pressure boilers and water tube boilers are high pressure boilers. So this fire tube boilers also. So coherent boiler, Lancashire boiler, and locomotive boiler. Okay. So like this, there will be a few specific cases also we have discussed. Okay. So with this, I am closing this classification of boilers. Thank you.